Today we're looking at a topic called association versus causation. We've been talking about how data sets in a scatter plot and a trend line can be correlated. So correlation is another word for association. And then what we're doing here is trying to determine whether there's a cause and effect relationship. And one of the biggest logical fallacy that we make is assuming that just because two things are correlated, that one causes the other. You can see this in social media and news all the time where they'll show data that something and something else are related, and they imply that one is causing the other without having the actual data to back that up. So here we're talking about filling in our notes. We've been looking at two pieces of data. So here, correlation, which we also call association, does not mean that one causes the other. So just because two things both increase together does not mean there is a cause and effect there. An example here that's a good one is if it's sunny, then it's going to be hotter days, like in the summertime, and ice cream sales are going to go up. So this is going to be a positive correlation between hotter days and ice cream sales. Also, hotter days where people are wearing tank tops and t-shirts and shorts, there are going to be more sunburns. So there's a positive correlation here too. You can write the word positive in there if you want, but I've just put a plus. So hot days, sunny days, cause ice cream sales and sunburn both to go up. So that seems like a cause and effect, not even directly, but these are correlated. So this has a positive correlation and that has a positive correlation, meaning that this one also has a positive correlation. So this is kind of like a triangle of things that all are correlated together. And the idea here is if you just look at sunburns and ice cream, and you have a scatter plot, and you have data that kind of shows as sunburns go up, ice cream sales go up. So it might look something like that for sunburn. So this is number of sunburns reported, and this is number of ice cream sales. And our scatter plot would probably look like there's a linear positive trend between those. And there's a correlation, there's an association, but that does not mean that one of these causes the other. And I know that can be confusing, the way we refer to this as an independent variable, and this is a dependent variable. It's kind of implying cause and effect between the two. But remember that independent and dependent are words that we use in science class. So in math class, we're not really saying that one is causing the other directly. The idea of science and doing experimentation is to figure out, while varying this one independently, while controlling it and making sure we know exactly what's going on with it, we look at what is happening to this one. So if we continue down here, we can observe correlation or association lots of times. Correlation or association can fit both. We can observe that between many variables, but it does not mean that something is causal. So they say it does not imply causation. Another way we say that is a causal relationship. That can be confusing because it looks like the word casual. So causation is when a change in one quantity or one variable causes a change in a second variable. It can only be determined from data collected from a controlled experiment. So that, again, goes back to science class and viewing the X as the thing we're controlling and varying in a specific way to see what effect it has on the other thing. So this is basically saying that things don't cause each other just because there is a positive trend. So here we want to decide if things are causation or just association, which is also called correlation. I think it's simpler here to use association so that we have A and C are two separate letters, because correlation and causation both start with C. So our test here, what we're going to be checking is, does one immediately and directly lead to the other? So no steps in between. We're not making up a story. We're not coming up with a way that we could get from A to B. We're just saying, is it direct cause and effect immediately? So if we look at the number of cold days and the amount of hot chocolate sold, so these are all assuming we have data to show that they are associations, right? So we're not going to say any of these are none. We're going to say that these are all going to be showing at least association and maybe also causation. So if it's not clear, association or correlation is within like a Venn diagram is a subset of, other way. So causation is a special kind of association. So association is broadly just meaning that there's a connection between the two, that they have a trend between them. Causation means not only do they have that trend, but also one directly causes the other. So causation is always a type of association, but it's more specific, like it's special. Okay, so the number of cold days and the amount of hot chocolate sold. So we could definitely see why there's an association, right? People like to drink hot chocolate when it's cold. But is it a direct cause and effect? Does cold result in buying hot chocolate? No, there's certainly like intervening steps in there, right? We would have to make up a story about, okay, it's colder, so we want a hot beverage, so we go and buy hot chocolate. So it's not like direct cause and effect. So we're going to call that one association. A car decreases in speed, the travel time to the destination increases. So that one, the time to get to destination is a direct effect of the speed the car is going. So if you reduce your miles per hour, then it takes you increased time. There's no like story in between there. It's a direct cause and effect between how fast you're going and how long it takes to reach a destination. So that would be causation. Age of a child and shoe size. So as children get older, their feet get bigger. That does not mean that getting older causes the shoe size to get bigger. So let's imagine. Oh, that one's tough. So getting older causes your feet to get bigger, but not necessarily, but we're saying there's an association here. So, as a child gets older, their shoe size gets bigger. And age is like direct cause of growth. As you get older, your shoes get bigger. So, I think we have to call this one causation. So, see. Number of hours worked and the amount of the paycheck. So, that one raises all kind of questions because some people get paid by the number of hours and some don't. But again, here we're assuming that all of these present some kind of a correlation. So all of these scatter plots would have some kind of relationship. So given that, then we would say it would be causal because working hours directly affects your paycheck. So if you think about your income as like a slope, you make some dollars per hour. So more hours, more dollars, right? It's a direct connection through that dollars per hour. So we'll put causation. That's a really funny C. Number of music lessons and amount of brain development. So this one, there's not a direct connection between those two. So is there some kind of correlation between them? Yeah, I think it's been shown a lot of times that kids that are more involved in music, arts, and things like that tend to do better on testing, better on scores for things and all of that. And what happens then is that it's put out as being in music causes your kid to be more successful or your kid to be smarter. But often what happens is both of these factors have a hidden third factor, like our friend the sun up here, causing both of those. And the common hidden factor here tends to be money. Because money lets you afford music lessons, and money also lets you afford books and tutoring and all kind of things that come with money that would allow you to have more brain development. So more puzzles, more games, more books, all of those things come from more money as well. So this is probably going to be an association because it's not a direct cause and effect between the two things. I kind of like what I said here as far as thinking about what your slope represents, because that's hours per, or dollars per hour. So dollars per hour, we have a direct connection. Going back up to here, our car decreases its speed, then we had miles per hour. So again, we have a direct connection between the number of hours and the number of miles as far as the speed the car is going. So I think maybe that's a good way of thinking of it is there anything in between the two, or do they directly connect in that way? Okay, high levels of social media usage and reduced grades in school. I would say no. There's no reason to say that one of those causes the other. So this one was a case of a third confounding variable that affects both of them. This one is we'd have no evidence for the directionality of this relationship or if there's another thing causing both of them. So reduced grades in school, maybe you're doing bad in school, so you go spend more time on social media. Maybe the relationship goes this way instead of this way. Maybe there are other things causing both of those, but there's not a direct cause and effect between those to where we don't have to make up some kind of story one way or the other. So since we have to make up a story to get from one to the other, we're going to say that's an association, not causation. This graph over here for ice cream sales, we can tell from this scatter plot there is a positive linear trend. It looks pretty strong, so it looks like if I could draw this line, which I can't. Let's see. There's a line tool somewhere here. Draw shapes, line. Ha! We're gonna draw a good line. Nice, right there. Okay, so we drew a line. That was quite an undertaking. And the dots are all really close. So we would say that this correlation is positive, it's linear, and it's strong. So strong, of course, we can use other methods to determine if that's actually strong or not. But yeah, it looks like those three things are all true. Does causation exist? Sunglasses sold and ice cream sales. So there's certainly no direct connection between those. So I would say no, there's no causation because there's nothing that directly connects sunglasses to ice cream without making up a story to get from one to the other. Like, oh, it's hot outside, it's bright, people need to wear sunglasses, and people want to get ice cream. As soon as we start making up that story, then we're going to say, no, it's not direct cause and effect. Draw a trend line. Hey, we did it. All right, cool. And then last thing on here, what kind of correlation exists? So this again is positive, linear. Hey, that was pretty good for not having the line tool. So same thing again, positive, linear, and looks pretty strong. Does causation exist? Total number of rocks and total weight. So I assume, bags of rocks. So you think about what this represents. We have a density of rocks, or I guess a weight of rocks. So each rock weighs a certain amount. So so we have like grams per rock. And that one is going to be a cause and effect because the rocks directly cause the weight to increase. There's nothing like in between. If you have more rocks, you have more weight. There's nothing like separate or intervening there. So I'm going to say causation does exist. I drew a trend line. Predict the weight of a bag with 35 rocks. 35 rocks. So we're extrapolating. So now I actually am going to draw a better line, which you would do with a straight edge. Let's see. Let's start here and go. Let's see. Let me make it. There we go. Okay. So we're going to go to 35, maybe something about there. And that's going to give us 35. It looks like around 100, maybe a little more. So about 100 grams. So True or false? If there are fewer than 15 rocks in the bag, then the weight is less than 40 grams. Fewer than 15. So we're talking about here over. So on all of our dots, that is true, but it doesn't mean, like, we see that there's variability in the rock's weight. So we can't say that it would always be true. We, for example, have this dot, which is right at 40 with like 12 rocks. So given that we don't know exactly what rocks weigh or a maximum weight, there's no way for us to guarantee that fewer than 15 rocks will weigh less than 40. That's impossible. In order for the bag to weigh more than 50, there must be more than 15 rocks. Well, we don't know that either, right? So that's saying here there need to be more than that to be above this line. So once again, all the dots are above that line, but it's not necessarily true. So we're going to put false for that. As the number of rocks increases, the weight of the bag increases. That's talking about that general shape of that trend line, and we saw that that is true. So that one is just a general relationship of the correlation, not something specific like these. Each of the rocks weighs the same amount. That's definitely not true. We can tell that very easily from the fact that this is not a perfect relationship. It's not a perfectly straight line. It's a scattered dot plot. Or a scatter plot? I don't know. The weight of 40 rocks will be greater than 100 grams. So here, our trend line, remember, went up here. So it certainly appears that it would be, but again, we could have outliers to where they weigh less. So there's no way that we can say that for certain. So this is, talking about the strength of the relationship, and we could do some more advanced statistic stuff to say what is the chance that 40 rocks will be greater than 100 grams. So if that kind of thing sounds interesting, then you should take statistics in high school, because then you will have ways to talk about standard deviations and probabilities and things where you could say there's a 3% chance that 40 rocks will weigh less than 100 grams or something like that. So there's a lot more within these topics than what we do in algebra. We just are barely touching a little bit of it to talk about the idea of association and causation, or correlation and causation, because people get it wrong so frequently, and it can be very damaging when the news and the media and social media get this wrong and imply that something is a cause and effect when it's actually not. So really important topic that's more a science than a math topic, but that's all we're going to cover from it here. If you are really interested in this kind of stuff, all the things we're doing with scatter plots and association and causation and linear regressions and all the things this week, then definitely take statistics later, because it's lots of that kind of stuff.